We're going to take a look at solving polynomial equations by changing it to quadratic form. Let's take this idea. If I have a quadratic such as x squared plus, we'll just call it 3x plus 1. What I'm going to do is I'm going to take this and make it a square. And this one and square. And actually, it doesn't even have to be with the 3. I'm going to take that. I'm going to take just the variables and square them. So what I get is x to the 4th plus 3x squared plus 1. But I could rewrite that as x squared squared plus 3x squared. Notice how this time I am not putting this other one here in parentheses. The reason I'm doing that, well, actually I'm going to put it in parentheses, but I'm going to put it with a 1. So here it was with the square on the outside and the 1 on the inside. So I am going to now reverse that. Instead of like that, I am going to do squared to the first, but it's the same thing. We multiply 2 times 1 and we get 2. We multiply 2 times 1 and get 2. But by doing it this way, I have a 2 here and a 1 here, which is the normal quadratic. If you saw x squared plus 3x plus 1, you would say, ooh, can I factor that? Or can I use the quadratic formula? You might not say that immediately, of course, but you recognize that that is a quadratic and a parabola. Well, what we're doing over here, and now let's take a look at number 1. What we're doing here is, even though this doesn't have a 2 here, it has a 4, we can rewrite it as a quadratic. And I'm going to do that by doing x squared squared plus 21 x squared to the first. 100 equals 0. Now, by doing that, I'm making it a second power, then a first power, then x to the 0 power, or just no x at all. That's a normal quadratic. The only difference for us is instead of just having x in here, we have an x squared. But as long as these two are exactly the same, we're allowed to do this. So now I'm going to say for a moment that x squared is equal to an x. And I'm going to say that I have now, that means replacing this x squared with x plus 21, replacing this x squared with x. And now that I've done that, I can solve that perfectly normally. That solves as x plus 25 and x minus 4. Once I've factored it, because that's what happens here, by doing a quadratic here, I can then factor it, or I could use the quadratic formula, because at this point now it is okay to factor or use the quadratic formula. But having done that, now I need to put the x squared back into this. So this x becomes x squared again. So now it's back to the real thing that it really is. And this one becomes x squared. And then I can solve each of them separately. I have an x squared plus 25 is equal to 0. And I have x squared minus 4 is equal to 0, which immediately we can see as x minus 2 and x plus 2 is equal to 0. Okay. Which means we have x is equal to 2 and negative 2 as 2 of our answers so far. This one we'll have to use the quadratic formula for, or will we? Well, let's think about that. We don't necessarily if we solve it, because it's only 2 and not 3 things. So we could with a 0 for, oh, I forgot to put, no, okay, we just simply solve this by doing squares. X squared equals negative 25. If I take the square root of that, I get a plus or minus here. Immediately, that I, or that negative, becomes the letter I. And the square root of 25 is 5. So that means, and here the square root and the square cancel. So I have x equals plus or minus 5i. So my solution set here is negative 2, 2, 5i and negative 5i. And to answer questions about that already, I can say that yes, it's acceptable to do plus or minus 2 and plus or minus 5i. Both of those are acceptable, but it's really not that hard to write them out. Okay, so after using quadratic formula for quite a lot of problems, we look at this, and on my first thought was, oh, I'll use quadratic formula, but I don't need to if I take the squares. And over here, I could have done that with the 4 and done plus or minus 4, and then had square root of plus or minus 4, except that this way, well, first 4 and then plus or minus square root of it. Could have gotten the same answer, but I like factoring it, of course. Now I'm going to do the same thing over here with this problem, number 2. Okay, so I'm going to write this as 3x squared squared minus 26x squared to the first minus 9 is equal to 0, and I'm going to say that x squared is equal to x, and then I'll do a simple 3x squared minus 26x minus 9 is equal to 0. That factors as 3x plus 1 times x minus 9 is equal to 0, except that these two now need to be replaced with the x squareds. 3x squared plus 1. Okay, I'll put that in red in a moment. And x squared minus 9. So it's x squared now for those. Well, that allows this second one to be x minus 3 and x plus 3 equals 0. So we know that x is equal to 3 and negative 3. And then for this one, I'll do 3x squared plus 1 is equal to 0. 3x squared equals negative 1. X squared equals negative 1 over 3, dividing by the 3 there. And then when I take the square root, and this I'll write out the whole thing, it's plus or minus. Don't forget about that plus or minus. So now we have a couple of issues with this little fraction here. Okay, so I'm going to do them first. We get a negative, so now I have an x here equals plus or minus. So I have an I, and then I have, well, actually look at that. That's square root of 1 over square root of 3, which means it's just simply times 1, and underneath it, it's a 3, or square root of 3. And the I is going to go in the back in a moment. So another way to write this would be plus or minus 1 over square root of 3i. You can put I on top of square root of 3, but you really shouldn't. It should be after the fraction. So our solution set for this one is negative 3, 3, 1 over 1 over, oh, wait a minute, I forgot something. Can't quite do that last one yet. Good thing I caught it here, because right now that means we have to rationalize this. So we have 1 over the square root of 3. We have to multiply top and bottom by square root of 3, because remember, you're not allowed to have a square root on the bottom of a fraction. You cannot divide by 0. You cannot have a square root on the bottom of a fraction. And you cannot have the letter I on the bottom of a fraction. So 3 things there to remember. So back up here, I need to do this as square root of 3 over 3i, because that I is still in place. And then negative square root of 3 over 3i. I'm going to make this neater. And here we have our solutions for it. So let's review again what happened here. Was to rewrite these, make that to be true. And then once we did factor it, then put the x squareds back in. Okay. And down here, remembering what to do with the fraction work to get the fraction part right. Okay, let's do these two. I would recommend to stop and do these for practice yourself. Pause the video and then come back to it and unpause it, and I'll start working on these. Okay, welcome back. I'm going to make this, let's put it back on the x squared minus 10x squared to the first plus 9 is equal to 0. So x squared is equal to x temporarily. So I have an x squared minus 10x plus 9 is equal to 0, which gives me, which gives me an x. Let's see, we need to make 9, so we need two negatives, x minus 9 and x minus 1 is equal to 0. Then we'll put those x squareds back in. Ooh, this one's x minus 3 and x plus 3. This one's x minus 1 and x plus 1. And they each get their own zeros. So x minus 3 equals 0, move it over. So that means we get that x is equal to 3, negative 3, 1, negative 1. Actually, I should put the smaller number first. Although I guess negative 3 would be, so it doesn't really matter. Just neat and orderly, so it's very clearly understood. Now, the last one, we'll do the same concept. X squared plus 48x squared to the first minus 49 is equal to 0. And then I'm going to say that x squared is x, and that allows me to say x squared plus 48x minus 49 is equal to 0. In fact, the 49 is so close to the 48, sort of gives away it. This is going to have to be a x plus 49 and an x minus 1 in order to multiply to make a negative 49 and add to make a 48. Now we'll put the x squareds back in. So this one's easy as x minus 1 and x plus 1. So we have plus or minus 1 right now as part of our answer. And then this one we'll do x squared plus 49 equals 0. X squared equals negative 49. Okay, take the square root, and I get x is equal to plus or minus the square root of negative 49. So square root of 49 is a 7, and the negative means I. So x is equal to plus or minus 7i. So we have plus or minus 1 and plus or minus 7i. Okay, one last thing to recognize about this technique is that we've been doing it with x to the fourths, but we could do it with others. For instance, if I had x to the 10th power plus x to the 5th power plus, say, 3, I could rewrite as x to the 5th squared plus x to the 5th plus 3. And then I could make that x to the 5th equals x, and I have x squared plus x plus 3, and I could try to solve it. Would that give me one? I think I should do, no, that one won't. I'd have to use the quadratic formula. But this was just an example to show that you can rewrite it like so. I could do the same thing with other numbers, but notice, in fact, let's do another number and then see the generalization of it. Let's do x to the 16th power. I'll say 7x to the 16th plus 19x to the 8th minus 23. Anything like that. Okay, now, in this case, this can be written because of the fact that that 16 is double the 8. I can write it as 7x to the 8th squared plus 19x to the 8th to the first minus 23. Just like this x to the 5th here is x to the 5th to the first power. So now I could write that, and I could say x to the 8th is equal to x, and I could do 7x squared plus 19x minus 23, and I use the quadratic formula. Notice in each of these cases, what's happening is that this one is 2 times that. And here the same thing, 16 and the 8. And all the ones we did with fourths were fourths 4 and 2, so they're all doubled. That's how you know that you can make a quadratic formula or put it in quadratic form. So you can put it in quadratic form if the degree is twice the middle term's exponent. One way to check that. Well, I hope this helps with recognizing all of these parts of solving. In some cases, not solving, but going over a couple of techniques involving factoring. But some of those can be done with solving without the y's in it if it's just x. But these techniques you want to make sure you're really comfortable with, that using factoring, you have to recognize it and look for it. Difference of two squares. And then trinomial factoring, whether it's a equals 1 or a is not equal to 1. And then we have grouping and the cubes. I really like the cubes. Make sure you're really comfortable having memorized the formulas with the cubes. And then using quadratic form or changing the quadratic form in order to help us to solve it. So there's a good deal in this section, but hopefully it just helps with understanding these different parts of it. Thank you for watching and listening.